Now we'll finish up this problem by finding the pH of a potassium acetate solution. What is the pH of a 0.325 molar solution of potassium acetate? The first thing we have to do is write the reaction that represents what's going on in this mixture. This is the reaction that we looked at from the first slide. All we're worried about is the reaction of acetate with water. So CH3COO- plus water in equilibrium with CH3COOH plus hydroxide. Now that we have our equilibrium reaction, we can set up our ice table. So we have I for initial, C for change, E for equilibrium. We have our initial concentration is given as 0.325 molar. Water we don't worry about. Our initial concentration of acetic acid is 0. Our initial concentration of hydroxide ion is also 0. Now we look at the stoichiometry of the balanced chemical equation to determine our change row. So I have minus x, and plus x. And for my equilibrium row, I simply sum up the initial and change rows. So 0.325 minus x, and x. Now I have my equilibrium concentrations with respect to x. I can use the information that I determined on the previous problem for my Kb value, and I can set up the Kb expression, which will be HA, and I'm using that as an abbreviation for my acetic acid, times my OH minus concentration over the CH3COO minus concentration. I know that Kb is equal to 5.6 times 10 to the minus 10th, and that HA and OH minus are both x, so I have x squared over my acetate concentration, which is 0.325 minus x. I'm going to make the simplifying assumption that x is much, much less than 0.325, and given the small size of my Kb value, this is going to be a reasonable assumption. So I can simplify my Kb expression, so I end up with 5.6 times 10 to the minus 10th equals x squared over 0.325. And when I solve for x, which is going to be my hydroxide concentration, I end up with 1.3 times 10 to the minus 5th. Now we can take the information that we know about the hydroxide concentration and we can find the pH of the solution. But first we have to find the pOH of the solution. So I know that pOH equals the negative log of my hydroxide concentration. So pOH equals negative log of 1.3 times 10 to the minus 5th, and I end up with a pOH equal to 4.89. And because no temperature is given, we're going to assume 25 degrees Celsius, and when I do that, I know that pH plus pOH equals 14, so pH will equal 14 minus pOH, or 14 minus 4.89, and we get a pH equal to 9.11. Given that this is a weak base, this acetate ion is behaving as a weak base, we expect a pH greater than 7, which is exactly what we see.